Welcome. In this video, I'm going to refurbish the displays in my 1979 Bally Star Trek pinball machine. Warning: these displays are driven by high voltages and need to be treated with respect. Do not try this at home. So you can see we've got our system in display test at the moment. Couple of things I've noticed with the displays on this. One, which is not happening right now, is that occasionally they will dim and flicker a little bit. You may see a little bit of flicker due to the camera right now, but in real life they're not actually doing that. And then the other is you'll notice on this display, which is the coin ball and play match display here, that we have a digit that's missing. Now, in this display, if I had the back glass on, you wouldn't see that because it only uses these two digits and these two digits. The center one and this one don't get used in this particular display. However, I'm still going to go ahead and try and fix that digit. And then we will also resolder all of the connectors and the grounds, because I believe a lot of the problem I'm having, I'll have, with some display issues and lighting issues, is probably due to bad grounds and possibly some cold solder joints. So we'll go ahead and reflow all those just to make sure. And what's causing this digit is most likely a bad transistor. So the way these displays work is through a multiplexing. And when the computer tells this to display 4s all the way across, it's not actually telling it to display 4s all the way across. It's telling it to display a 4 here, then a 4 here, then a 4 here, then a 4 here, then a 4 here, and a 4 here. And it's doing that so fast that your eye believes that it's on all at once. And this is why if you're looking through cameras and the shutter speed is wrong, you will see a flickering effect here. It is doing this at a high frequency, relatively high frequency for the human eye, so you can't see it, but that's why it works that way. So what's happening is that the transistor that turns on this digit is probably bad and just simply needs to be replaced. And again, we'll reflow all the connections and just refresh the displays a little bit. All right, so I have pulled out the display that had the missing digit. The other ones are fine, so they're just going to need just going to reflow their connectors and call them good. However, this one does need a repair. So what we need to do is figure out what's causing this most significant digit to not function. So looking at the schematic, the way this works is you have your different segments, A, B, C, D, E, F, and G. That's what turns on the different portions of the 7-segment display. And then you have the transistors back here that basically turn on which digit it's going with. So you got A1, A2, A3, and so on and so forth. A6 happens to be the one that's not working on this one. So what could be causing this is a couple of things. One, so this A6 is going to its ground via this transistor, and this is probably the most likely thing. It's this 2N5401 transistor, and the way we're going to figure this out is I'm going to go ahead and do a test on either, it's possibly this 2N5401, it could also be this Q6 transistor. So these are basically taking in our 5-volt signals all down this way, and then this transistor is turning on the signal to this transistor, which is switching the actual high voltage portion of the signal. So those are one possibility. There is also R1, R3, and R5, and then I believe it's these three right here. This is coming from Joe's Classic Video Games. So if we look at R1, that's this transistor here, R3, R5, R7, R9, and R11. So every one of those transistors could be suspect as well. If they burn up, they would prevent this transistor from turning on. So what we're going to do is do some quick testing. We know that all the other digits work, so I should be able to look at, say, Q11 and Q5 and see if they are causing the problem and measure measure Q11, Q5 so we know what it should look like, and then compare that to Q12 and Q6. All of these resistors should be 100K resistors, so we should be able to just do a quick test on those. So that's probably our simpler test, so we'll go ahead and start there. Turn our multimeter on here. A little slow to react, but it does its job. So 100K. And keep my pins on it. 100K. Okay. That was 155K. It's a bit high. And 17. And look at that, R11 is open. I think we may have found our culprit, being a simple resistor. So I need to grab a 100K quarter watt resistor. We'll verify that in our operations manual. Make sure that R11 is what we believe it should be. Assuming that I actually have that parts breakdown in here. It may not be. Oh, display driver, yep. R11 is 100 kilo ohm. So let me step out, grab my resistor collection, and we will swap that resistor out and see if that solves our problem. All right, so I've got my 100K resistors here. Pull one out. And just to verify, we're going to go ahead and measure this out of circuit. Make sure I didn't just miss my connections. Completely open. Measures in circuit at 100 kilo ohms. We're going to go ahead and test Q6 just to make sure. Extremely hard to read this board with all the dust on it. Let me see, maybe I can. All right, so Q6 is right here. So what we're going to go ahead and do is I'm going to test Q5 first. So we'll switch this over to diode test. And the way a transistor works, it's just two diodes back to back. So I should get, depending on how I'm connected, so I get a 0.6 drop there, a 0.6 drop there, and if I switch my connectors, I get nothing, I get nothing. So again, I should get nothing, nothing. .6 drop, 0.6 drop. So I suspect that transistor is okay. The only other one that could be bad would be Q12, which is probably going to be up here. It's this transistor up here. Again, we're going to use Q11 as our baseline. And nothing. Nope. 0.7. Five 5.6. So again, it looks like Q12 is responding the same as its neighbor, which was working. So we're going to go ahead and I'm going to bet that that resistor fixed our problem. We're going to go ahead and flip this over real quick. And throw some flux on these connectors and do a quick solder reflow on all of these, adding a little bit of solder to each one as we go. I'm seeing some indication up here that we might have a little bit of cold solder joint going on. So I'm going to go ahead and touch those up as well. And we will see if this fixes the digit issue. The rest of them will basically be the same process. I will reflow the pins here. All the other digits are working, so I'm not worried about them. And then we'll clean up the boards and put them back into service. So. And the one last thing I'm going to do here, again, these pins don't seem too bad. There's a little bit of corrosion on them. But we're going to kick the camera. Sorry about that. Let me get you back in here. Now, don't beat me up about this. This is 2000 grit automotive wet dry sandpaper. This is slightly less abrasive than most toilet paper you find in public buildings. So, but it will take that basic corrosion off the surface. And then we will let our alcohol dry and put this back in service and test it out. Again, we'll repeat the reflow and pin cleaning on all the others, and we will go from there. Hopefully this will solve our digit problem. Okay, so we got our first board display repaired. That one was the bad resistor. The rest of these displays aren't in need of repairs, but we're going to go ahead and clean up their pins and reflow them. Just a word of caution. And this is something I learned on that last board through experience. Be very careful when reflowing these. So these are high voltage pins, and if you add a bunch of solder to them, it's very likely that they'll bulge out a little bit, they'll get close, and it could arc. I ended up blowing a fuse that way. Went back and cleaned up all the solder sucked it all off, and then reflowed them again with a minimal amount of solder. So again, what we're going to do here for the most part, we're just going to reflow these pins. We're going to use some isopropyl alcohol, clean up the board, and put her back in the system and test it out. And I'll do this for 4 more displays, this display plus 3 more. That'll finish all 5 displays, and I will just put this in super speed and we'll buzz right through these. Alright, we're coming back to another display here. So, what's happened? All of them cleaned up well and they all seem to work pretty good, except this one. One segment out of the whole display, so if you're looking at it straight on, this bottom left segment is not turning on all of the digits. Now, understanding how these work helps understanding the troubleshooting of it. So the way they work is the system sends which segments should be turned on and then which digit it should do that, and it does that in sequence at a really high rate of speed. So you don't see a flicker in it. Cameras can, but basically the fact that the same segment is out on all of the digits tells me that it's the driver for that segment that's out, not necessarily anything more dramatic than that. Now it could be the BCD, the 7-segment display chip, possibly, not likely. More likely it's a issue with the transistors or one of those components in that area. So if we look at our schematic, first there's a little diagram here that shows you all of the segments. So we're looking at segment E, which is going to be Q17, R29, R21, and R22 related to that. So let's see. We're looking at Q17. So we've got 13, 14, 15, 16, 17. So we're going to go ahead and put this into diode check. Transistors are essentially just two diodes back to back with points. So let's look at Q16. So we're still having a little bit of issue. We're having the single segment out on all of the devices. We checked the transistors. They seem to be okay. Resistors, they all seem to be okay. Another possibility is this chip here, which is binary coded decimal to 7-segment decoder. However, I'm not really willing to check that on the machine live because there's high voltages in there. I can't test it on the bench because I can't light anything up without those high voltages. And because of that, if this chip is bad, I'm going to have to replace it, which means I'm going to put in a socket. To find out if this chip is bad, I need to pull it off the motherboard, so I need to put in a socket. So either way, we're going to pull this chip out. I'm going to put in a socket, and then we'll throw it into a tester that I've made with the Arduino. Hopefully the tester works. It's untested an untested tester at this point. But let's start by removing this this chip. All right, there is our chip ready for testing. Let's grab a socket. Nice little 16-pin socket here. Our socket is now in place, and we can take a look at this chip. Maybe straighten the pins out a little bit. And our pins are straight. And I'll bring out my tester here. So I put this in place with pin 1 to this end on this side. Based on the pin out, all of my outputs to the LED should be over here. I'll flip this board around actually so LED is right side up. Slip my power supply board down in here, and hopefully make sure none of my messy resistors here are touching each other before I get too far ahead of myself. All right. 0, 1, 3. The program doesn't seem to be working. I'm going to go ahead and take this up to my computer and do some testing. And I will come back and show it functioning. Whether the part is bad or what, I don't know. I doubt it, but the only way I will know that is to turn on some serial monitor stuff and monitor it on my computer, see if the outputs are putting out what they're supposed to, and then we'll go from there. So let me stop this video, go troubleshoot the test rig, and then I will be right back. I have returned after troubleshooting some code, now functioning. Good news is, if I turn this on, we have a steady count. Bad news is that means that this chip is good and it's doing what it's supposed to, which tells me I'm still not sure why I'm having troubles with that segment on the particular display. So, go ahead and shut this off, and go ahead and pull my chip back out of here. Sure I will. There it is. Take a quick look at our pins, make sure we don't have any bad solder blobs that'll jam up in the socket. Make sure our pins are facing, pin 1 is facing the right direction, and we plug this into our socket. At this point, again, I need to do some testing, see what's going on. First, let's clean off the solder flux we're putting our socket on. And I'm going to go attempt to test this in the machine and see where it goes from there. It could have been a bad connection on the chip. We'll give this a try. Alright, so where we left off was display 4 had the lower left segment here on all of the digits was out. What that indicates is that the segment driver, in this case segment E, is not working. Most likely cause is Q17. So be careful, because there are all of these transistors, and these transistors. There's two different types on this board. There's these, which is the MPS A42s, and then these, which are the two N5401s. They are not compatible. Do not mix them up. So make sure that when you're replacing Q17, you put the right type of transistor in there. So that's what we're going to do. That's the most likely cause of a segment failure, would be Q17. It could be there's some resistors and stuff that could be causing the problem, but the most likely cause is that Q17. So far, my luck with most likely causes has been pretty nil. So we will see how this works out. And that gets downright hot. Okay. So, again, make sure you have the right one. This is my MPS A42s. I just got myself a collection of these because why not? The biggest trick here is trying to get your pins in the right position, because they really didn't lay these out with the actual footprint of these in mind. They just kind of made up their own. With that, we have a new transistor on segment E. A little bit of cleanup, and we will give that a try. I put this back in the machine and went to test it and immediately blew the display fuse. Pulled it back out, and we have a short between ground and high voltage. So if we jump up here, I take my ground and my pin 1 high voltage, I'm getting about 0.3 ohms to ground. Now this high voltage, if you look at how it comes in on the schematic, it comes in and the first thing it hits is a capacitor that goes to ground. Hits a test point, and then it feeds all of these transistors. So there's a couple of possibilities. One, a transistor here could be shorted, but again, it would have to be one of these transistors that goes straight to ground. I don't think that's really likely. I think more than likely I have this capacitor C2 has failed and is causing the short to ground. I'm not sure if I have one of these, but we're going to pull this one out and see if that eliminates the short to start with. If it does, I'll pick up a capacitor if I don't have one in the building already, and we'll go from there. So let's give this thing a little bit of flux. Hopefully, if this is our problem, taking that out will eliminate our short. Nope. So it was not that capacitor. what I've found is there's a little solder tag sticking out here from this joint, and it was touching the trace next to it because these solder masks are so broad, have such broad openings. So what we're going to do, per my son's recommendation, which is actually the right way to do this, is we're going to unsolder that so we get all of that excess solder off and then reflow that joint correctly. Just running my probes in between there broke enough of it to fix the short, but we're going to reflow that correctly and go from there. So I've sucked all the solder off of this, and I no longer, it's a very clear separation there. Looks like 27 kiloohms, 28 kiloohms. So we've got a good high resistance here, and probably charging up a capacitor somewhere. So anyway, super high resistance. This is what it should be. So we're going to jump in here, resolder these connections with a little bit of grace. Still a good 28 kiloohms. So I've got this, oh, where did I put it? Oh, there it is, hiding underneath it. So I've still got to get this capacitor back in. This is clearly not failed. Actually, let's test the capacitor for resistance. Should be, yep, it's an open connection. .32 nanofarad, which is supposed to be 0.01 microfarad, which is 10 nanofarad. Yeah, good. We got a good 70 kiloohms. So we're going to clean that up, test it out, and see if that fixes our display issue. Again, we're back to what we originally did, is we replaced the transistor in here, Q17, and hopefully that will fix our missing segment. And now that we've got our short fixed, we should be able to plug it in without blowing any more fuses. And I will stop right there and bring you back when I get the display in. So as you can see, our E segment is now working correctly. That would be the bottom left segment down here. All of the displays have been refurbished and gone through. Lessons learned in the process of doing this: double check, double check, double check. No, don't just visually inspect. Check with an volt or with an ohm meter. Make sure that there are no shorts between your high voltage and your grounds, or your, basically make sure that you don't have any shorts between any pins that shouldn't be connected. I knew this. I did this on several of them. I didn't do this on the last one. Again, blew a fuse. Not that a fuse is the end of the world. It did what it's supposed to, is protect the system, but it could be a lot worse if that fuse doesn't fail. If somebody, you don't notice, you get a new machine and somebody has modified that fuse and put in a higher amperage fuse than should be there. But overall now, all the displays are refurbished. The power board is next. It's actually been repaired already, but that's in the next video behind this. Again, I had a problem with the power board wasn't controlling the high voltage anymore, so I had to go and fix all that before I could continue working on the displays. The final one is my light driver board, and I've got a few lights out on the thing. Oddly enough, when I fixed the power board, it fixed several of the lights that weren't working. I don't know why, but because of that, that'll be the last board I go through and do the modifications and changes, and then the electronics on this will be up to date. Still have the oddity when you hit the flippers that a lot of the lights dim, which I'd like to look into that and see why that is and fix that issue. Other than that, we're almost complete, and this machine will be put in full service and ready to play for anybody who wants to in the house. So at that point, I will leave you. Thanks for watching. Please like, subscribe, comment. I'd love to hear your comments. I'll do videos based on questions that are asked if I can. And just enjoy the engagement and the feedback. So with that, I will see you in the next video.